Hi guys, this is Mrs. Berg again. I know that you love hearing my voice and not seeing my face, but we'll do our best. Okay, so just a couple reminders. If you want to go to extra help, you can see Miss Divine. She's gonna actually be in room D112. Um, and or you can go see Miss DeGracia, and she's gonna be in 136, which is right next door. Okay, if you have any questions. And don't forget, you can always rewatch this video as many times as you want when you go to my website. Go to the folder that says Berg, and then you can watch it again. You can look at the keys. You can do whatever you want. Okay? And make sure you're doing your homework, because it is going to matter when I come back. I'm going to be able to tell who's doing their homework or not. Okay? All right, so let's talk about what we're going to do today. So today what we're going to do is we're going to continue talking about similarity. We're going to talk about scale factors again, and what's different is that we're going to dilate when the center is not at the origin. So that's what's going to be a little different from yesterday. The procedures will look the same. We're still going to talk about similar concepts, but there are a couple things that are going to be a little bit different. So let's take a look at the do now. Hopefully you've kind of looked at this a little bit already. So the question says, what's the scale factor for the dilation shown here? Okay, so now when I'm looking at this diagram, I can tell which is the pre-image and the image, because the image has the primes and the pre-image doesn't. So I can tell by this dilation that an enlargement has happened. So um, I know that my scale factor is going to be greater than 1 because there's an enlargement. Okay, so let's take a look at. So now, what do I know about writing scale factors from yesterday? I know that I must always write as a scale factor, which is K. I'm always going to write, it's always image over pre-image. Okay, so because I know which is the image, now I pick two corresponding sides of the shape. It doesn't matter which two, because dilations have similarities, so it doesn't really matter which way, which two segments I pick, as long as they're corresponding, so they have to match up. So let's say that I'm looking at AB and A prime B prime. Okay, so now I'm thinking, which is the image? What's the length of the image? Oh, the image is the ones with the prime, so that has to be 25. Okay, and the pre-image is going to be 10 because that doesn't have the primes on it. So it's 25 over 10. Is that greater than 1? Yes, it is. So I did a good job. I can also simplify it if I wanted to, right? I can make this 5 over 2. So there's my scale factor. Two most important aspects of dilation. I need to know what? In order to dilate, I have to know my scale factor, okay, which we already went over. That's going to be image over pre-image. And we need to know the center of dilation. Okay, very important. So yesterday what we did is we talked about how do we dilate when the center of dilation is at the origin. Today we're not going to do that. Today we're going to look and see what happens when the center is not the origin. So let's take a look at an example together. The procedure is the same. The procedure will be the same. So that's going to be nice for you guys. But the origin or the center will change. Okay, so let's take a look at the question. Graph rectangle EFGH with coordinates E, F, G, and H, and its image after a dilation with a scale factor of 1/2 and a center of dilation at 2, 0. Here's what the notation looks like. And now let's think about how this is different. This is different because now the center is not the origin. The center is not going to be the origin. Okay, so that is going to be different. Now let's think about the image. Is it going to be larger or smaller than the pre-image? Well, let's look at K. K we said was 1/2, right? 1/2 is less than 1. So that means that I know before graphing it that my image is going to be smaller than the pre-image. There's going to be a reduction, in other words. Okay, it's going to be a reduction here. Okay, so now let's go ahead and see what the procedure is, similar from yesterday. The center of dilation is going to be what? 2, 0. Okay, very important. Everything comes from the center. All of the movement is going to come from the center, so we have to be really, really good at using the center and understanding why it's important. Okay, so let's go ahead and take a look at our shape here. Let's plot the coordinates first of our pre-image. So we have -2, 2, or -2, -2. this guy will be E. And then we have negative 2, 4 will be F. 2, 4 will be G. And then H is going to be 2, negative 2. Okay. Oops, that's H. Okay. Okay, so here's my image. That's my rectangle. Very importantly, we have to now plot the center. The center is very important. 2, 0. It doesn't matter what you call the center. Let's call him C because C is not being used. But really that has to be the most important part of the dilation because it's going to tell me that's my point of reference, right? I'm always going to start counting from C. I'm always going from C. Okay, so let's kind of review what we did yesterday. It's the same procedure, but now C is not at the origin. That's the only thing that's different. So when I look at point E, let's start at point E. From the center to point E, I need to count the rise. Am I going up or down? And the run, am I going left or right? So when I start at C and I'm looking at point E here, how do I get from C to E? Well, I'm going to go down 2. So the rise is 2. And I'm going down, so it's going to be negative 2. And then the run, right or left, is going to be 1, 2, 3, 4. To the left, so it's negative 4. Now what I do is I have to multiply those distances by my scale factor. Okay, multiply by a half. You can do it in the calculator if you want, or you can just do it fractionally. So I'm going to end up with negative 1 and negative 2. So what does that mean? That means that that's a new distance from C. It has to be from C. Okay, so you're going from C, and now it's going to be negative 2, so you're going down 2. And then the run is negative 2, so we're going to go to the left 2. There is my new point. There's the image. Okay, then I do the same thing with F. Where's F? F is up here. So rise over run, right? Or rise. First, let's count the rise and then the run. We're going up 4, so that's positive 4. And then we're going to go left 1, 2, 3, 4. So it's negative 4. The run is negative 4. I multiply each by my scale factor. So I get 2 and negative 2. So now, again, from C, that's my point of reference. You always start counting from C. From C, my run is positive 2, up 2, and my run is negative 2, left 2. So there's going to be F prime. Now, as you're doing this, I want you to keep in mind what we talked about yesterday. The point of the center of dilation, the pre-image and the image all have to be collinear. So when you find your point, just kind of double check to see if they're on the same line. All these 3 points have to be on the same line. If they're not, then you've done something funny and you have to go back and look at it, okay? Let's go to G. Where's G? G is up here. So from C, what's the run? Or sorry, the rise. So we're going to start rise first and then run. So from C to G, we're counting. So we're going up 1, 2, 3, 4. Positive 4 because we went up. And then the run is going to be 0 because we're not going right or left. We're staying there. So the run is going to be 0. Still multiplying by 1/2. So we're going to multiply by a half here. This is 0. 0 times a half is 0. So now from C, we're going to count 2 rise and then no run because there was 0 run. So there's my new G. That will be G prime there. Okay, and then let's do the last guy here, H. H, we're going, what's the rise? We're going down 2, so that's negative 2. And then there's no run, right? We're going to stay, there's no right or left movement, so that's a 0. We'll multiply by the scale factor, and we get what? Negative 1 and 0. So what does that mean? That means, again, from C, always start from C. We're going to count. The rise is negative 1, so down 1. And no movement right or left. Let's see, 1, 2, 1. Hold on, guys, let me just check something here. 1, 2, 1, 1. got something weird here. Okay, sorry. I made a little mistake. I plotted E wrong. I did the math right, but E is plotted wrong. So just fix E for me. I couldn't figure out why it looked funny, but now I can see what I did. So if you go to E, back up to E, so it's down 1 to the left 2. So then it should be here. That's why it looked a little funny to me before. Okay, so now let's finish it off. So H was 2, -2. And we're going down 1, and then there's no rise or no run. So it's going to be right here. And then that is H prime. Okay, so let's go ahead and plot or connect the segments here. And there's your image. You guys see how there's been a reduction there? It looks smaller, right? And you can double check. And again, keep in mind certain things we talked about yesterday. The segments are parallel to each other. The pre-image and the image segments, so these have to be parallel because that's what happens when you dilate. Parallelism is preserved. And so when I start at my center, here's my center. And the center, the pre-image, and the image should all be collinear. They have to be on the same line, right? And they are. I can check by just looking, right? I can check that they're all the same line, and they are. So I did a good job. Okay? So that's how you dilate with the center is not the origin. It's the same idea as what we did yesterday. But what's a little different is that now you're not going from 0, 0. Now you're going from any point, and I can dilate with any center. Okay? If you have any questions, please go see Miss Divine or Miss DeGracia. I will see you guys. We'll talk again tomorrow. Well, not really talk, but you will hear my voice tomorrow. Okay? Bye, guys.